Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we solve one numerical which is based on the theorems of a symmetric and the skew symmetric matrix. So already we have studied the two important theorem which is related to the symmetric and the skew symmetric matrix. So the theorem one says that, so for any square matrix A, if we take for any square matrix A with real number entries, so the condition is what? The A plus A dash, this gives the symmetric matrix. Okay, and if suppose if A minus A transpose, if we just take, so this will be the skew symmetric matrix. Okay, now that will be the theorem 1. So this will be the theorem 1. The second theorem indicates that second theorem states that, so again for any, okay, we take any square matrix can be expressed as a, it's a sum of symmetric and skew symmetric matrix, symmetric and skew symmetric matrix. Means we can express the any square matrix as a sum of symmetric and the skew symmetric matrix. That is the theorem 2, but the theorem 1 is what? A plus A transpose is a symmetric and A minus A transpose is a skew symmetric matrix. But when we write the second theorem, I can represent this like here. So if I take the square A is a square matrix, so this gives, so you can take this is A plus A, that is a symmetric. Again it's a sum of, means it's a plus we have to take, so A minus A dash. Okay, so this is the second theorem, but for a simplification purpose we just take here, it's a half, here also we have to take half. Okay, again this will also relate to the property of a transpose of a matrix here. So now this is your second theorem. Now based on this, okay, based on this second theorem, we will go for the one simple numerical here, so which is important here. So what he has given the matrix A here, so if suppose he has not given the, he has not indicated the matrix here, so but we consider this is a matrix A, so which is of 3 cross 3 matrix here, 3 rows and 3 columns are there. Now if I take, let A is equal to the given matrix here, so I will take this is 3 minus 1 minus 2 2, so 1 minus 4 minus 5 and 2. This is the 3 cross 3 matrix here. So I need to express this 3 cross 3 matrix as a sum of the symmetric as well as the skew symmetric matrix. Now I have to prove this condition. Now if suppose if I take this entire term as some P, so this entire term as some Q, so I have to prove that the given matrix A is equal to P plus Q. Okay, that's our intention here. Now this is a matrix A, so I have to find out this A transpose now. So again I'll find out what is the A transpose. Then what I'll do, so I'll just take the separate here, what is the P, this is the entire term, and again I'll find out the Q here. So by taking this entire term, then I'll add both the term P and Q. If suppose if I'm getting the original matrix A, so this indicates the given any square matrix can be expressed as a sum of the symmetric and the skew symmetric matrix. Okay, let us find out. Let us find out, this is a square matrix here, given A matrix. So I'll find out what is the A transpose here. So transpose is nothing but just interchanging the rows to columns here. So just take the first row and write it in the first column, take the second row, write in a second column, minus 2 1, take the third row and write it in the third column, minus 4 minus 5, and this will be the 2. Now this will be the, okay, that is the A transpose here. Now let us consider P is equal to half into A plus A dash. Just I am taking this part here. Okay, now I'll just take here, this is a, I have to find out this entire term. So this is A and this is A plus A. So this is 3 plus 3, because I have, okay, I'll write in complete form. This is 3 minus 1 minus 2, this is 1 minus 4 minus 5 and 2. This is matrix A. So plus matrix A transpose. A transpose means this entire matrix I'll write here, 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1 1 2. Okay, this is A transpose. Now the matrix addition is very simple, right? Okay, we will go for the matrix addition here. So only thing is we have to add the corresponding elements in both the matrix here. It's a 3 plus 3 6, 3 plus minus 2 is 1, minus 1 minus 4 is minus 5. So minus 2 plus 3 is plus 1, minus 2 is minus 4, plus 1 minus 5 is minus 4, minus 4 minus 1 is minus 5, minus 5 plus 1 is minus 4. So 2 2 4. Okay, this is a A plus A transpose. Again I'll just simplify, means multiply this half into entire all the elements here. So this becomes P is equal to, finally, so just multiply this half, that is 1 over 2 in for all the elements. It becomes 6 by 2 is 6 by half is 3. I'll directly simplify here. This is 3. This is 1 by 2. This one I'm taking, that is half into, that is 1. This is half. Again half into minus 5. That is minus 5 by 2. So again this half into 1. So minus half into minus 4 is minus 2, and this becomes minus 2 again. So take this term here, so it becomes minus 5 by 2. So for this term it becomes a minus 2 here. Again for the last term this is a plus 2 here. Now this is my matrix 1 here. I'll just take, okay, let it be. So this is my matrix P. Again similarly Q is equal to, let Q is equal to what I'll take, this is half into A minus A transpose. Just like for the same thing, we'll go for what is the Q here. So this becomes half into matrix A is the entire term as it is. So directly, okay, let it be. This is 3 minus 1, this is minus 2 minus 2, this is 1 minus 4 minus 5, and this is 2. This is matrix A. I have to take the minus transpose, again the transpose of A. This is 3 minus 2 minus 4, 3 minus 2 minus 5, so minus 1 1 2. So this is A transpose here. Now the simplification, that is a matrix subtraction here. So 3, this minus 3 of 3 means 3 minus 3, it becomes 0. 3 minus into minus plus 2. So 3 plus 2 is 5. So minus here, this minus into minus plus 4. Minus 1 plus 4 is plus 3. Minus 2 here. So this is minus 3, it becomes minus 5. So again minus 2, minus into minus plus 2 here, it becomes a 0. So 1, this minus into minus plus here. So 1 plus 5 is 6. So this is minus here. So minus into minus plus. So this is plus 1. This is minus 4. It becomes a minus 3. So minus 5. So this is a minus into 1 is minus 1. Minus 6. Okay. The 2. So this is plus into minus 2. Plus 2 and minus 2 is 0. So now this is the matrix Q here. Now just multiply this half into all the elements here. So this becomes, so this become a 0. So this is 5 by 2. So 3 by 2. So again this is minus 5 by 2. So again it is 0. So 3 minus 3 by 2 minus 3. Again this is 0. Okay. Now this is the matrix Q here. Now what I have to find out? I need to find out this is a, okay, according to the theorem, this is your, that is a transpose, that is a half into A plus A. Okay. Now this is a symmetric matrix here. So this is a skew symmetric matrix what we are getting here. So I need to find out the P plus Q. If it is equal to the given matrix A, then we can, okay, then we can prove, then we can say that for any square matrix we can write it in the form of a, it's a sum of the symmetric and the skew symmetric matrix here. Only thing is what I have to add. So these two terms now. So that is these two matrix if I add. So if I add these two matrices, if I get it, if I suppose if I am getting the original matrix A, then this A can be expressed as a sum of the symmetric and the skew symmetric matrix. So we need to remember that. So the properties are very important, properties as well as the theorem 1 and 2. Now consider P plus Q. So P plus Q is equal to the matrix P is, so that is a 3 half, so minus 5 by 2. So the second row is half minus 2 and minus 2. So minus 5 by 2 minus 2 plus 2. We have to add here. Take the Q matrix 0, 5 by 2, 3 by 2. So this is minus 5 by 2, 0, 3, minus 3 by 2, minus 3, and this is 0. So this is the matrix here. Now the matrix addition is very simple. So we will just go here, one term here, 3 plus 0 is 0, this half plus 5 by 2, okay, minus 5 by 2 plus 3 by 2. Now this is half minus 5 by 2. Now minus 2, same as it is, minus 2 plus 0, minus 2 plus 3 is plus 1. So minus 5 by 2 minus 3 by 2. So this is minus 2 minus 3 is minus 5. So plus 2, 0 is 2. Now we will simplify here. You just see here. So first term is 3. The second term is, if you take the 2 as a LCM here, the numerator is 1 plus 6 is 1 plus 5 is 6. So the denominator becomes a 2. So we are getting a 3 here. So again minus, if you take the 2 LCM here, so this is minus 5 plus 3 in the numerator, that is a minus 2 divided by 2 is there. So we will be getting a minus 1 in the, as a solution. So this is again the LCM is 2. So this is 1 minus 5 is minus 4 in the numerator. So if you divide here, so we are getting minus 2 again. So again this will become a minus 2. So this is plus 1. So here it's again minus 5 minus 3 in the numerator, it is a minus 8 by the LCM 2 here. So we are getting minus 4. So this is minus 5 and this will be the 2. So now we just compare, okay, we just compare the PQ matrix. So just see here, this is a 3 3 1 3 3 1. So second row minus 2 and 1. So minus 4 minus 5 and minus 2. So from that we can just say that this P plus Q. So this P plus Q is equal to the given matrix A here. Therefore we can, from this we can prove that any square matrix can be expressed as the sum of symmetric and the skew symmetric matrix. Hence P plus Q is equal to the given matrix A. So we can just say that therefore any square matrix can be expressed as is a sum of symmetric and the skew symmetric matrix. I hope you are getting this one. It's a very simple symmetric and the skew symmetric matrix. I hope you are getting this simple numerical here. It's not a difficult, it's a very simple thing. Okay, the only thing is what we have to remember that what are the properties of a transpose matrix, what is the symmetric and the skew symmetric matrix, and what are the theorems which is related to the symmetric and the skew symmetric matrix. So if you like this video, please comment, share with your friends and subscribe to our channel. Thank you.